didn't get it stabilized enough. But instead of, okay, so picture this. So this is the item, sorry, this is user ID and this is item ID. It's calling into the prediction service and it's doing a dot product on the user ID's vector, which in that one master picture that we're going to keep going back to, LiveRex2. This isn't showing. It's so weird. I think someone say highlighter show up. There we go. Okay, so after we've separated out, right, we've factored out these two matrices, or that one matrix on the left into the two on the right. I can now represent items by this vector. That's item 1, and I could do that vector for user 1. So if I'm trying to find a prediction for what does user 1 think of item 1, I'm going to do dot product and get one value, and that's the prediction. So that's exactly what's happening here. I can show you the code. User item. Everything is under this prediction, or yeah, it's under my apps serving prediction. So here's the actual, or the user item prediction command, and here's, I'm going to compare it to the batch one. So what I'm getting at here is, okay, so the user ID comes in, and the item ID, I've already stored inside of Redis each of those vectors. So grab me so here's the user ID. Really get me that vector. We're using the like raw JBLOS stuff, which is used by Spark on like the inside, but I've just pulled it out to just use this library. I'm creating what's called double matrix, but here I'm just passing the vector. This is just for that one user, the 4 values or whatever it is. For the items, put that into this double matrix, which is a vector, and then call dot product. And that's the exact like prediction that would have been, or that is predicted by Spark if you, yeah. So anyway, that would be. So picture a whole shit ton of these coming in all at once, right? So this is Netflix. People want predictions for this user, for this item, this user, this item. As all these come in. So let's say that they don't share this. It's not for the same user, right? So I can't use any caching or anything like that. But instead of, and think of a GPU. So I'm doing this one calculation per request, and it has to pass from CPU memory into GPU memory across this slow-ass PCI Express bus, just to do one vector by one vector. So that's not really efficient, right? So Hystrix gives you the ability to batch up. And so we can use Hystrix's batching capabilities in this clever way where we actually build up a bunch of users times a bunch of items. So have it every 20 milliseconds, give me all the data that's come in, all the user and item, dot product, build out one matrix for each, and then just do one big ass dot product. And then on the way back, we just send to each caller the specific answer for that user item pair. Right? So I started to get that to work this morning. Didn't get it to work, but this is essentially what you would do. Instead of taking in just a single user ID and a single item ID, which is how the other one works over here, you would batch them up and do the user ID array and an item ID array. You just kind of have to know the first one goes to the 0th goes to the 0th over there. There's more clever ways to do it where you can actually pass in the tuples of these things. And then on the way out, you would just return. So when you multiply all this together, you then end up with one vector. And so the 0th item is for the 0th user and that kind of thing. Right? So this is actually batching up at sort of the application layer. knowing that my hardware is a GPU or yes, even CPUs would benefit from this, right? Because yes, anytime you can sort of vectorize and really pass in more data and fill up the registers and all the data is there when it needs to be, versus one request coming in at a time doing those calculations. So yeah, keep an eye out for that. That's actually one of the open issues that I've been working on. So what's interesting is that TensorFlow serving actually does this. I mentioned TensorFlow serving this morning. They actually do, there's ways to configure it, and it's specifically for this exact reason. So I was reading the TensorFlow paper, and reading about TensorFlow serving, some of the optimizations that it makes, knowing that it's going to set these to GPUs. And that's one of the things it does. It can actually build up larger and larger matrices as needed. Picture two, if you're doing like one matrix, you can sort of put them edge to edge, or tip to tip, I guess you might want to say, corner to corner, and just keep an eye on the offsets, pass that whole thing in, have zeros for the rest of it, and do these huge matrix multiplies all in one, and then come back and parse out the answer based on the upper left and the lower right kind of thing. Or where that would end up in the resulting vector. So there's fun little performance tricks like that that make huge, huge differences. If people are leaving, if they have to go outside for whatever reason, how does that work?
Yeah, we can come to it.
Okay. All right. If you guys have feedback, like you back there, come talk to me, because I want to, I'm serious. I don't want to bore you to death. And, I don't want to get sidetracked on specific things, so tell me where I'm going astray, and we'll fix it. I'm here for you guys. All right, I guess let's see. Yeah.
So for the incremental learning, did you have the code yourself, or did you use some library for it?
Yeah, there's another library that I picked up. One of my coworkers from Databricks. It's documented in there, but it's streaming. I think it's like streaming matrix factorization. Yeah, it's this guy Burak. The thing is, and you can see it in the issues. I'm one of the main people creating issues in this repo. It's just not production ready. It just wasn't. It worked in a a unit test scenario, and so we were going back and forth with Burak. He's actually one of the guys that's like heading up the whole group, building out the whole Netflix data pipeline. So he has way more important things to do than to help us get stream matrix factorization working. So. Snapped his code, have disclaimers everywhere. This is his code. Basically, completely refactored a lot of it. There's still a lot of to-dos, like things I don't understand why this request would be public and stuff like that. So, but the goal is to get this sort of running on its own, just to prove it out, and then other people can come in and try their better algorithms. There's definitely better algorithms for this, but this is all Burak stuff here. Yeah, this is using indexed RDE.